So more inverse stuff. So like we just talked about, some calculators don't have keys to evaluate the secant, the cosecant, and the cotangents if you need to do an inverse. So you have to use another function, but we have to make sure that the ranges match, and so the only buttons that we have on our calculator that we have inverses for are inverse sine, inverse cosine, and inverse tangent. So somehow we have to match these up. So what is the range from the inverse sine? So if you take an inverse sine, the angles that it returns are going to be between which values? Yeah, negative pi over 2 and pi over 2. Okay. Out of the secant, the cosecant, and the cotangent, which one of these three has the same kind of range? Which one of these has the same range? The cosecant, right? It's normal reciprocal function. So the cosecant, so the inverse cosecant can be found by using an inverse sine button. Are we okay with that? Okay, the cosine runs from where to where? From 0 to pi. So inverse cosines is going to give an angle between 0 and pi. Okay, so that, hopefully this one is clear. It is going to have to be used for your secant. How about your cotangent? Where does that go? 0 to pi. So for some odd reason, the inverse cotangent is going to have to be found by using an inverse cosine button. You can't use an inverse tangent button for it. I mean, you sort of can if you're in quadrant 1, but if that angle is negative, then you or that value is negative, you're going to have a problem. Okay, so I always use the inverse cosine button, partly because I always have to draw a picture because I don't have it all memorized. So what does that look like when you set up a problem? Okay, so the secant, the inverse secant of something, of 5, is supposed to give you an answer with, well, that's actually going to return me an angle to me, so I'm going to rewrite this in its inverse relation. So that means that the secant of some angle is supposed to give me a 5. Okay, so in what quadrant am I? So that I can draw the right picture. Yeah, I'm in quadrant 1. Okay, everything that's positive is in quadrant 1. Okay, so in quadrant 1, the 5 actually can be shown with a 5 over 1. So the 5 is your hypotenuse, right? And the 1 is what? It's your adjacent side, right? Okay, so if you want to find this angle, what are you going to be able to use? The inverse cosine of 1 over 5. So if I use this, I will get the right answer. Okay, so this one is the way it's supposed to work. The secant, the inverse secant, can be found through the reciprocal function. So just use the inverse and then use the inverse of 5, which is, or the reciprocal of 5, which is 1 over 5. Well, whatever the calculator tells me here then should work. So this ends up being 1.37 radians. Okay, how about the cosecant? The cosecant can be found by using the inverse sine, right? So since that's exactly the way we would expect it, we can just find the inverse sine of what? Not negative 4 over 3, but (3 over negative 4). And obviously it doesn't matter where the negative is. So if you put this in your calculator, this should work, and you would get an angle of a negative 0.85 radians. Okay, so these two work the way that you would expect them to work. Yes. Notice that the ranges were given in radians, right? So yes, please write them in radians. Can I move on? Now we're going to go to the oddball. So the oddball in this little story today is the cotangent. Because for some reason the cotangent doesn't work with the tangent, because the domain and ranges don't match, right? Well, the ranges do, but alright. First I gotta switch this thing here. So your book's been using those expressions, so keep in mind that you can rewrite these. So the square root of 3, you can divide it out. So actually this would be the same, 1 over the square root of 3. Yeah? Alright, so let's see. We're in what quadrant? 1, because it's positive. So you can draw this triangle with the cotangent being adjacent over hypotenuse, right? Adjacent over opposite, so that's 1. This is your square root of 3. So here's the triangle that works for us. We're okay? Alright. What angle is this? Not, this is 60, right? The angle here is 60, so it's pi over 3, and we're in quadrant 1, so here's my answer. I'm okay with this answer. I don't have to worry about it. In quadrant 1 things work out. How about the next one? So I don't have to rewrite it. Okay, I'm going to rewrite it from this perspective though. So the cotangent of some angle is supposed to be negative 2 over 3. So in what quadrant will I be? I'm in quadrant 2. Okay, again, the cotangent is adjacent over opposite, right? Yes? So there's your negative 2. There's your 3. Your triangle is going to look a little bit like this. Is that a special triangle? A triangle that we know? No. Okay, but I do know that the cosine of this angle would be a negative 2 over, and I need to find this value over here. Okay, so why am I looking for a cosine here? Square root of 13, right? Did I not do that right? Okay, 9 plus 4 is 13. So why am I grabbing a cosine here? Because I need to go from 0 to pi, and the only function on my calculator that has an inverse button is the inverse cosine, so I need an inverse. I need to think in terms of the cosine here. So this is what I know. Then the angle can be found by using your inverse cosine button and plug in a negative 2 over the square root of 13 on your calculator. Okay, and if you do that, your angle should be 2.16, and that's radians. Okay, and that is between pi over 2 and pi. Are you guys okay with this? Okay, so this is your oddball. Gonna move on? Okay, so this is supposed to be the easy stuff today. Okay, so the second part is to write algebraic expressions for trig expressions. One reason why I want to do this is so that it's easier to come up with a graph for these. So for example, I have no idea. If I looked at this as a function, if I said, hey, my function is the cosine of the inverse sine of something, I have no idea what that looks like. But if I can rewrite this as an algebraic expression, then I actually know what it's going to look like. And this is definitely awkward. So please bear with me. So I'm just going to work on the inside part here again. So I've been doing this for a while now. So that has to be true, right? The inverse sine of u is supposed to give me an angle, right? Okay, so instead of writing this, so this is sort of complicated, can I not just rewrite this expression as then the cosine of some angle and define the angle by the inverse sine? Are you okay with what I did? Okay. Alright, so if the inverse sine of something is the angle, then the sine of the angle will give me u. Is that right? Well, that's the connection that I need here to rewrite this as in terms of an algebraic expression. So I want to write everything in terms of u. Well, now I know that u is the sine of the angle. So it would have been great if this said sine of theta. Well, it does not. So how can I go from having this as a cosine? How can I write this only in terms of sines? Okay, so what happens here is that I want to write everything in terms of the sine function only. So what relationship do we know between the cosine and the sine? What identity? Yeah, but that introduces a third one. I just want a direct, I want an identity that only has a sine or a cosine in it. So which identity do we know that uses a cosine and a sine? Does this one look familiar? No. Okay, well that's the one we need. What I want to do is replace this cosine with something in terms of a sine. So first step would be then to rewrite this one as the cosine of theta is 1 minus the sine squared of theta. We're okay with that? How do you get rid of this square? How do I make this say just cosine of theta? What do I need to do? How do you get rid of a square, guys? Well, then let's write it this way. And then now we can replace the cosine of theta with this. So the cosine of theta would be the same as taking the square root of 1 minus the sine squared of theta. And the sine of theta is worth how much? Well, then this can be rewritten again as 1 minus u squared. So the expression 1 minus u squared is equivalent to writing cosine inverse sine u. They're the same. What I'm skipping here is sort of a discussion about domains and ranges and all of that. Okay, technically this only works if u is what? U would have to be between a negative 1 and 1 here, right? Otherwise it doesn't work. You can't have a negative square root. It just doesn't work. Are we okay with this? Okay, well that would be rewriting a trig expression as an algebraic expression. I'm going to do another one. Alright, same start. It's sort of difficult to look at this inverse tangent. So the inverse tangent of u is going to give me an angle. So instead of writing this mess, I'm going to replace that just with the sine of some angle. And since I want to replace the symbol for angle, the theta symbol, with u's, then that means that the tangent of the angle, if I could just write this all as tangents, then I would be much better off. So all of this is going to be in terms, that's an R in there, in terms of tangents only. So what do we know about tangents and sines? What relationship do we have between the tangent and the sine? Okay, now you can use the one that you said earlier.
So cosine plus sine. Oh, sine divided by cosine.
Okay. The reason it works on this one you'll see here in a little bit, but so to create a tangent here, I'm just going to multiply by the cosine over the cosine. And the whole reason that I'm doing that, again, is because Kate said that the sine of theta divided by the cosine of theta is what? Okay, so we are halfway there. Unfortunately, when this cosine scoots on over, it does leave a cosine of theta over here. Okay, now, how is this beneficial to us? Well, there is a relationship between the cosine of theta and the tangent of theta that's direct. So, well, it's sort of direct. So what other relationship do we know that deals with tangents? That somehow has maybe another type of equation? The what? Yeah, the secant squared of theta is equal to the tangent of theta plus 1. And the secant is what? The secant is 1 over the... So there's your link to get from a cosine out to a tangent somehow. Okay, so I want to write this side as a cosine. So the first thing I'm going to do is to get rid of this square. So how do I get rid of the square again? Okay, so I'm just going to take a square root. And the secant is what? The secant is 1 over the cosine. So that means that if I flip this upside down, I will just get a cosine of theta over 1, which is just cosine, right? So the cosine of theta is the same thing as, yeah, put this over 1 over the square root of that mess. Are we okay on that? Because now I can replace the cosine of theta with that thing. So the cosine of theta is actually the same as 1 divided by the tangent square of theta plus 1, and I do need to take a square root here. Okay, how did that help? Well, the tangent of theta is worth how much? The tangent of theta is u, and so that means that you get the square root of the tangent squared, then would be u squared plus 1, and then multiply these together to finally get an algebraic expression that would be the equivalent of what we started with. So u divided by the square root of u squared plus 1 is the same thing as sine inverse tangent of something. Okay, and that's what you're supposed to be doing when it says rewrite it with an expression. Anybody have a question on that one?